Okay, next we will discuss one important concept, that is call by reference. Uh, let's take one example to understand the difference between call by value and call by reference. Suppose there is one function that takes two inputs a and b. Then it contains the statement a greater than b question mark a colon b. Then the main function suppose contains these statements int a b. Suppose a contains the value 5, b contains the value 10. After that you are passing these values to the get function. Then you are printing the value of a. So what this will print, let's see. To this get function you are passing the value of a and b, that is 5 and 10. Then at this point a equals to a greater than b question mark. That means if this condition becomes true, then the value of a will be assigned to this a, or otherwise the value of b will be assigned to this a. So for this case this condition becomes false, so the value of b, that means 10, will be assigned to this a. So after this function call you are printing the value of a here. So what does this print? It will print the previous value of a, that is 5. This change will not be reflected in the calling function because you have passed just the values, and this function does not return any value to the calling function. So it will print the value of 5. So if I compile this program, then if I run it, you can see this change is not reflected here. Now if I modify the function like this, suppose in star a star b, then star a equals to star a greater than star b question mark star a colon star b. So now a and b are pointers to the integer type data. That means a and b now can hold the address of integer type data. So here to this get function you need to pass the address of a and address of b. So now this star a indicates here the content of the memory location that is pointed by a. So the value of star b is assigned to the star a. After this function call you are printing the value of a. So here the change in the value will be reflected because you have passed the addresses of the data items and you are changing the values through the addresses. That's why for such kind of function call, that means call by reference, the change in the value will be reflected in the calling function itself. So let's see, if I compile then run, you can see the change here. So this change is reflected here for call by reference. So this is the main difference between call by value and call by reference. Now we will see how pointers can be used to represent an array. Suppose there is an array A6. So this 6 is the size of this set. That means it can hold maximum 6 elements. So for this A, you may know that an integer type data takes 4 bytes of memory. So for this case 4 into 6, that means 24 bytes of memory will be allocated for this A. But if you take one pointer to represent an array, the first thing you need to do, you have to allocate memory for this p. So for this you need to have dynamic memory allocation. So for dynamic memory allocation you can use two standard library function. One of them is malloc. Malloc function takes one input, n is the number of elements, then multiplied by size of int. This returns 4 bytes. So now if n is 6 or 10 or whatever the value, it will allocate the memory for this p. So there is one more standard library function for dynamic memory allocation, that is called calloc. Calloc takes two inputs, the number of elements, comma, size of int. You can use any of them for dynamic memory allocation. If you want to use a pointer to represent an array, so for using these standard library functions, you need to use the corresponding header file, that is stdlib.h. So now take one example, a simple problem. Suppose you are given a set of numbers, suppose 56, 39, 44, 17, then 99, then 65. So it contains 6 elements. Now you have to search for a number that is present or not in this list. So for this case, what you need to do, you need to compare the value with each of the elements sequentially. Then if a match is found, you can say that number is present in this list. Or if you don't get any match, then you can say that number is not present in this list. So this is called linear search. So let's implement this. Suppose you are defining one function search, and it takes int star a, that is the set of the numbers. Then it will take the number of elements, then it will take the value that you need to search in this list. So after this you need to take the counter I equals to 0. Then you have to use one loop. So the condition is if I less than n, then you need to compare the values. So if ai equal to x, so for this case if you use an array, then you can use this ai, but here you are using a pointer to represent an array. So this ai will become star of a plus I. So this indicates that particular element ai, star of a plus I. So if it equal to x, that means that particular value you want to search. So if this match happens, then you can say that %d found at index %d. So x found at index I, then break. You don't need to compare anymore. So after that I plus plus, then this loop closed. So this loop will search sequentially starting from index 0, and it will compare with the value. So after that, if no match is found, that means if I equal to n, then you can say that %d not found, that means x. Okay, so this is the definition of this search function. So now you need to first define the main function here. So suppose the number of elements is n. So you need to first take the number of elements from the user through keyboard. That means enter the number of elements, then scanf %d %n. So n will hold the number of elements in that list. Then after that you are taking one pointer to represent an array, that means that particular list. So in star b, then b equals to in star malloc n multiplied by size of int for dynamic memory allocation. Then you can use any one of them, malloc or calloc. So then you need to take the values for that list. So enter the elements. So after that you need to use one loop for taking the values into that list. So I equals to 0, I less than n, then I plus plus, then scanf, then %d %a, sorry it is b here, b I. So if you use an array, then you can use this statement %bi, but you are now using a pointer to represent that array, so you need to use here just b plus I, that indicates the address of that particular element bi. So just you need to put here b plus I, that indicates the address of that particular element. So after taking the values for the set, then you need to call the function, right? So you can call that function search, then you need to pass the set of the numbers, that means b, then comma, then the size of the set, that means n, then you can take one value. Suppose you want to search for 100 in that list, or you can take one more variable. So you now can put it that enter the number to search, then scanf %d, then %j. You need to search for this j now, right? So you are passing this j to the search function. You don't need this. So that's it. This is the code for linear search. So let's run this program. First compile, then run. Enter the number of elements, suppose 6. Enter the elements, suppose 56, 39, 44, 17, 99, 65. Enter the number to search, suppose 100. 100 not found, it is not present in this list. Then you can take one more, so 6, then 56, 39, 44, 17, 19, 65. Enter the number to search, suppose 99. 99 found at index 4, 0, 1, 2, 3, 4. So this is the code for linear search. Now suppose if the problem like this, suppose you have a sorted list, 17, then 39, then 44, then 56, 65, 99. So now you have a sorted list and you have to search for a particular number that is present or not in this list. So if you use this code for this particular problem when the list is in sorted order, then it is not so efficient, because what is happening in this case, it is comparing with each of the elements from the starting index. Suppose you have to search for 99, then it will start from 17 and it will go on. Then at the last it will find one match. So this code is not so efficient for this case. So the main point is when you have a sorted list, you need to use binary search for searching a number present or not in that particular list. So what will be the code for binary search? Binary search, in this case, what will happen? First, you need to compare with the middle element. You need to compare with the middle element, and if that particular element is greater than the middle element, then definitely that number is present in the right half. And if that particular element is less than the middle element, then that number definitely is in the left half. So for this case, you need to go like this. First you need to have the set of the numbers, then you need to have the starting index of the array or the list. Then you need to have the last index. Int first indicates the starting index, last indicates the last index of that particular array or list. Then int x, you have to search for this x into that list. So then for binary search, the main point is you need to compare with the middle element. So int middle, then while condition is if first is less than equal to last, then this loop contains if star of a plus I, that means a plus middle, that means if the middle element equal to that particular number x, then you can say that %d found at index, it will be middle. So what is middle? Middle equals to first index plus last index by 2, that is the middle index. So if this match happens, then you can say that x found at index at the middle index. So after that you can use this else if the condition will be now if star of a plus middle less than x, then what will happen? Then definitely x will exist in the right half of that list. So for this case, the first index will be changed to middle plus 1. The last index will be same. After that, else means this else indicates if star of a plus middle greater than x, that means x definitely exists in the left half of the middle. So for this case, the last index will be changed to middle minus 1. That's it. So this is the case for this loop. Now after this loop, if the condition is if first greater than last, then you can say that %d not found, that means this one. That's it. So this is the function for binary search that will search for a number in a sorted list. So after this function, you need to call this function from main. So this will be same for binary search also. You have taken the number of elements, then you have to take the values for that list, then enter the elements, then enter the number to search, then J, then search, then it will be B, then first index is 0, then the last index means n minus 1. So you are passing this to this binary search function, binary search. So that's it. This is the code for binary search. But one thing keep in mind, this searching technique will only work when the list in sorted order, or it will give wrong output. So it is very much efficient to search for a number when the list is in sorted order. So let's run this. Compile, then run it. 6, enter the elements, then suppose 56, 78, 99, 110, then 150, then suppose 200. The list must be in sorted order. Enter the number to search, suppose 150. Okay, 150 found at index 4, 0, 1, 2, 3, 4. So it is fine. Now check once more. Suppose 1, 4, 6, 9, 12, 15. Enter the number to search, suppose 11. Not found. So it is running appropriately. So this is the code for binary search. So in this way you can use pointers to represent a list or an array.